Alright guys, this is just going to be a quick video. I've been working on getting some character recognition stuff going, and in the process I made this little program here, which I will launch and show you. So this is XML Data Point Viewer. Let me go ahead and load up a file here real quick. Sorry. So let's go with character dataset large. That's what I want. Okay. So this XML file, which is what you see here in the background, this XML file just has, well, it has two distinct data sets in it, and one of them is for symbols. So these are just the basic math symbols: plus, minus, plus, times, minus, divided by. Okay. And then the second data set is numbers: 1, 2, 3, and 4. Okay. So I just want to talk a little bit about this program that I wrote here and how you can use it. All it does is it expects you open up an XML file, right? That's the guy I just loaded. And it looks for a data set and whatever data points, right, you have in there. It dumps them into, by default, it'll make a square grid big enough to fit the data, right? I have 25 points here, so it made it 5 by 5. For my output, I have 4 points, so it made it 2 by 2. It won't let you do anything stupid, like I can't put a 1 here. It'll just make it a 2 again. So I can make this 4 by 2, and you'll see it just shrunk there. I can make it 4 by 3. If I wanted to, you'll see it runs out of the 4 data points and then it's just gray. I can make it 4 by 4, so it just goes across, for instance. And then there's some spinner controls, right? So this, I'm looking at right now data point 1 of 4 in this first data set, right, which is this upper spinner. And I can click through it and it'll fetch this data and draw a black pixel. So it draws left to right, top to bottom. It'll draw a black pixel wherever this data is greater than 0, and then white pixel wherever it's 0. So these are like blown up real huge. It'll show you, right, I'm on 2 of 4. There's the third one. There's the fourth one. Okay. So you can see here in the background, this is 0, 1, 2, 3, 4, 5, 6, 7, etc. A bunch of zeros and ones. I've already done all the work for you, so they're all there. I'm going to give you guys a link to this so you can load it up and try it. And I'm going to give you guys this, this little app, this rinky-dink thing I made. And you can kind of click through your data. The one thing that's goofy, right, so this defaults to 5 by 5, which is working out nicely because I have 25 points here. If I mess with this, if I make it 6 by 5, let's say, I guess that doesn't look too bad. Let me make it 6 by 6 and like skew everything. So you'll see it looks like garbage because now I'm running 6 across, so it doesn't know the difference, right? The fit button will reset it to the least perfect square that fits it. So if you're going to do something that's, say, 4 columns and 5 rows, you're going to have to go in here and set this to 5 by 4 manually, because it's, I think, going to just default to 5 by 5. Anyway, I'm sure you'll figure it out. So let's see. So this is char dataset large. This is my first data set in this XML. This is the first data point, so this is just the plus symbol, and you'll see I have, let me make this just 1. These are the output values, right? So in mine, I decided to do it where I have 4 symbols, 1, 2, 3, and 4, and this is the input. Over here is the output. You'll see that I light up just the first one. You can see here this 1, right? This is my 1 node, which is going to be a plus, I guess. This is the times output. This is the minus output. This is the divided output. Okay, so I decided to represent my output data that way. You could do it any other way you want. And to illustrate that, I did it again with this second data set. So this is the numbers 1, 2, 3, and 4, and I'm sure you just saw what happened there. So for these guys, and they are way down here. Let me collapse my data points. This guy, so this is the digit 1, right? Isn't that obvious? you'll see here the output is just the first node is turned on. The next data point, this is the digit 2, all the pixels, but you'll see that I've highlighted number 1 and number 2, okay? So I decided just to do it that way because you can represent your data however you like, and hopefully the network can do it, and I guess that's really the question. So you'll see here, this is my digit 1, this is my digit 2, you'll see that now I have 2 of them highlighted. This is my digit 3, it's bigger because I thought it looked better, and there's 3, and then here's my digit 4, and all 4 are lit up, okay? So let me go back to my neural network class here, and let's do it. So you'll see I have this set up to load. This is char dataset large, that's this XML file I'm using. The cool thing about this is that when I want to flip back and forth between the data sets, right, they are both children of the document element, and so I can use the child nodes array and do either 0 or 1 depending on what I want to load. 0 is the first one, which is the symbols, okay, and so let me go down here and make this char rec symbols, so character recognition symbols, because I want to save the output assuming it converges so I don't have to train it again. And this is my cool error history thing that it spits out, so we can plot it in Mathematica to see how it converges. Another important thing, this one seems to work fine still with only 3 layers, one of which is just a buffer, one of which is just linear, which is kind of impressive actually. The first time I did it, I gave it 4 layers, 2 sigmoid transfer functions in the middle, and a linear output layer, but it still converges this way just fine. One important thing to notice, right, I had to move the number of input nodes up to 25 because, as you'll recall, here there are, right, 25 pixels, so I have to give it 25. For the hidden layer, I picked 35 pixels, kind of arbitrary, slightly larger. There is a nice rule of thumb that I want to say is like 150% of whatever the input layer is, but again, that's totally up to you. There are, again, 4 output pixels because obviously I have 4 choices, the digits 1, 2, 3, or 4, right? Similarly, I guess I'm doing symbols, so it's these 3, 1, 2, 3, 4, sorry, these 4, just like that. So if I run this, train, no problem. I didn't even make it to 500 iterations. I went back and turned on the notification so I could see it. So that seemed to work out just fine. Let me open this guy up. Char rec symbols. Alright. So my error started off at 422. Went up to 515, went to 151, and wow, it actually converged pretty quick. Made it in 112 iterations, so that's fairly impressive. Let me do the numbers, and I can do that by doing the following. Choose child nodes 1, right, because I have both data sets in there. I'll leave the network to be the same, I don't know what you would call it, architecture, same topology, I guess is the correct word. Same number of nodes in each layer. And then this is going to output to numbers, and similarly here I want to output to numbers. Save it, run it, and that one converged again, no problem. Char rec numbers, 38 iterations, starting at an error of 780. Actually pretty good. Alright, well I guess that's good news. Let me open up Mathematica here. Oh, my cat is present. Let's see, so we set directory. I have this all lined up to work real easy. So first I'm going to load character recognition symbols. So this is the first guy. So this is a plot of the error. Let me go ahead and make the range like 0 to 1, 0 to 2, something like that. This is the error from, from the 4 math symbols, right? So this actually, it converged pretty easily. No big deal. Not that exciting. I've run this, a few times. I actually haven't had it hang ever. With 35 nodes in the hidden layer, there's a lot of different degrees of freedom, and it seems to be totally a non-event for this thing to converge on these 4, which is great because if maybe one of you guys gets less lazy than me and makes all 10 digits, it would still work out just fine. And I'm sure I'll do it later. I'm just feeling lazy right now. So I'll do it also with character recognition numbers. These guys are the digits, right? So that's second data set, numbers 1, 2, 3, and 4, with my different style of output, right, for the data. And one of the things that's kind of cool about this version, right, is you don't have to be, I don't know, sometimes it's easy to get stuck thinking about, oh, I should make the network output this way. There's one symbol, here's a second symbol. That makes sense. And I could have done the same thing here. It could just be 1, you know, when the digit is 1, 2 when the digit is 2. Or what I did instead was I decided these are going to highlight, or these nodes are going to fire anytime the input number is greater than or equal to their node number, right? So 1 is on because it's 1. Both 1 and 2 are on because I put in 2. Both 1, 2, and 3 are on because I've input a 3, etc. Right? And that's kind of cool because I could put in any digit, and if, I don't know, the third node lights up, I would know that number is bigger than 3. So I don't know, just a different way to look at it. So don't be too close-minded when you design your data sets. So plotting that one, not that interesting because there's only 35 of them. Maybe I'll run it again. Hopefully get something different. Numbers. Okay, this one took 118. That's a little bit better. Let me go back and load this again. Okay, so there you go, pretty spiky. Every time I've run this, it's never ever nudged. I have the nudge window set at 500, so it never got a chance. I set it real low to see what it would do, but it was always making progress. So I don't know. I guess it's working out really well. Maybe these data sets are way too easy for this. Not sure. That's probably what's going on. But that's good news because that means it's a flexible model. So anyway, this is a quick little demo of this stuff that I'm going to put out there. I'm going to give you guys a link in the comments down below for this. I don't think it should crash on you. I wrote it kind of ad hoc, so don't expect too much. And I included, I think, all the DLLs you're going to need. It'll just be in a zip file with a couple of DLLs. For any developers out there, if you recognize those DLLs, don't judge me. I know that's old, but anyway, you'll get it. So I'll include that. Don't need to save that junk. And I will include the data set that you saw earlier. So these guys. And you can use this to open up this program, which is somewhere. And you just click load. Let me go to char data set. So here's my first one, right? This is 9. This is a 3 by 3 times plus divided by minus. I guess this should be bigger. Oh, you know what? This was just when I was messing with it. I don't have the output done for this guy because I thought it looked stupid. And here's some other testing crap. Alright, I don't know why I showed you that. Anyway, I'll put the stuff up and hopefully you guys dig it later.